Good morning, everyone. Welcome to the July Innovation Forum meeting. For those that this is your first camps event, welcome. So just a bit of background on our Innovation Forum. We meet once a month, the first Wednesday of the month, with the exception of July being that we just had the 4th of July holiday. So we get together for 1 hour each month, and it's really a forum for us to have interaction, collaboration around innovation. So obviously, innovation encompasses quite a bit under that umbrella. So we try to mix up our topics and our guest speakers for each month to really keep the discussion lively and to really focus in on what's relevant and what's of interest to the campus community. So for this month, we are extremely excited to be joined by Max Ismailov, who is the founder and CEO of Rocket Propulsion Systems, as well as a fellow Purdue Boilermaker, where he got his doctorate in rocket propulsion. So Max's company really is on the cutting edge of building, testing, and commercializing innovative propulsion systems. So very excited to be speaking with Max today. And with that, I'll hand it over to Max.
Yeah, thanks, Norman. Great to be here. Thank you for inviting. I'm happy to answer any questions or interest that you may have.
Perfect. So I guess top of mind, what inspired you to start Rocket Propulsion Systems?
So it's an interesting time in space technologies right now. Not long ago, only the governments had the means and resources to do business in space. It has changed in the last 2 decades. Some new players emerged, mostly billionaires and other rich organizations, but now it's becoming more of a business that ordinary people can come into and do money in. So so let me segue into some scenarios that you might visualize in your head. Imagine you're a farmer in Eastern Washington, and you have a crop, you have a field of some crop that you're growing, but you need to understand, okay, where is it now in March? How did it grow over March, July timeframe? Where should you put more seeds in September? And how do you capitalize on that knowledge to save on cost for the next year? So turns out that nowadays there is small satellite technology available and affordable, and those small satellites can do Earth observation for you, look at your essentially field of crop in Eastern Washington and tell you exactly what's going on with your crop on a monthly basis, on a weekly basis, even on a daily basis if you wanted it. Another use case, I guess, imagine you're a captain of a big barge going through a Suez Canal, and you don't want to get stuck in the Suez Canal, and you don't want other ships complaining about you getting stuck in the canal. So turns out, to not get stuck, you can use the help of those small satellites in space and get updates on a minute-by-minute basis or an hourly basis, according to whatever is comfortable to you to do that navigation through the canal. Or imagine you're a Trader Joe's, store manager, and you're thinking, okay, my parking lot has pretty tight spots. I'm in California in some busy neighborhood, and I really need to know what my customers are doing, how they're parking, how long they're spending in the parking spot, how they're turning, what to do about this traffic to increase customer flow. again, turns out you could use small satellite technology to get those updates on a minute-by-minute basis and understand whether you need to expand your parking lot or really attempt to make those parking spots wider. So, um, so well, what does it take to have that small satellite technology? Well, first of all, you need to launch those small satellites. But going back to why it's so attractive and why ordinary people are interested, well, here's why. So we're talking about small satellites of about this size. I don't know, people in this audience, they probably imagine when we talk about satellites, they probably imagine something like a school bus, somewhere out there in space, taken out by NASA. No, we're now talking about small, rockets lifting this size of a small satellite into space, and that satellite, it does those observations for you. Now, it costs about $300,000 to make this small box, but you can make anywhere from $6 to $10 million a year on this box, doing this Earth observation. And so you can see that jump in numbers just on that small box. And if you have 50 of them, so that you can get consistent coverage in that spot that you're observing, well, then you're making a lot of money. And so, well, the question then becomes, well, how do you get those satellites up into space? And, one of the most common options right now is to go ask big rocket manufacturers and launch providers to essentially piggyback, on their big rocket and get those small satellites into space. Now, the big rocket providers, the big launch providers, they're like an Amtrak, that is traveling from Seattle to Chicago. And they're going to drop you off in Chicago, but you need to get to Kokomo, Indiana to do that Earth observation on your field of crop. Well, the problem is nowadays you don't have a car to get you from Chicago to Kokomo. You need to essentially walk. That's the state of the space technology right now. Now, there is a less common option. You can go ask small rocket builders to get you straight to Kokomo instead of being dropped off in Chicago. The problem is, this rideshare option, it costs about $2 million. And the small rocket option, direct to Kokomo, that's a $10 million option. And so 95% of the people, they go and choose the rideshare to Chicago, and they prefer to walk. Now, the rideshare option, it has its own sort of hurdles to overcome. It takes about a year to wait in the queue because there's a lot of people that want to build those small satellites and make money on them in space. And so you need to wait about a year in the best case to get on the big rocket to share the ride. And then the walk from Chicago to Kokomo, that's going to take you another year. So 2 years, you're essentially waiting for that small satellite to start generating money, and you're paying overhead, on Earth to keep the lights on. So now the question becomes, well, why are those small rocket providers, why are those so expensive? And the answer turns out to be that the motors, the engines on the small rockets are very expensive. And they're expensive because they're built according to old, essentially models, designs. And so what our company does, we innovate in how to build really affordable, cheap rocket engines so that those small rockets become competitive with the rideshare. Hope it all makes sense.
Yeah, no, I appreciate the analogy. When you talk about rockets, I know there's so much complexity and depth. So I do appreciate you lowering that complexity down so we can understand it through that analogy. Um, and the cost is just, I mean, I guess it does make sense. Can you talk a bit more about what your company is doing to make it more affordable and more accessible for folks? I know that you're doing a lot of exciting work in the space of hydrogen energy. Can you talk a bit more about the affordability work that you're doing?
Yeah, so we started this company in 2019, so we've been around for 4 years. Not a startup anymore, I guess, but still a young company that is trying to make its way in the world. So again, what we do, the core of our business is we innovate in propulsion technologies in the rocket engines. And our main question is, how do you make them cheaper? How do you make them? Let me say this. So right now, right, there are rockets that have. Let me bring this analogy into play. So right now, the rockets are like you have a truck, a Cadillac truck, with a Ferrari engine inside. And what we're trying to do is we're trying to essentially build a Chevy truck with a Chevy engine inside that is very, very cheap and affordable. And so, so the way we innovate with our propulsion technologies is we make big use of additive manufacturing, trying to find ways to how to smartly combine additive manufacturing with traditional manufacturing techniques, how to use computer modeling to essentially iterate on the designs very quickly. So what I mean by this is we have the capability to iterate through hundreds of different designs and arrive at an optimal design very quickly. The other area that we iterate in is how to test the engines more efficiently and at a more rapid pace than it used to be in the past.
That rapid prototyping is very, very interesting. Can you talk a bit more about the iteration process that you've been using? Maybe some tips and tricks that you could share with the CAMPS community that might be transferable to our discrete manufacturers that make up a lot of the folks on the call here.
Yeah, sure. So that sort of directly touches on the manufacturing aspect. And since we're in the hardware space, our business, it may be pretty applicable to some people here in the audience. So rocket engines, for a long time, they used to be made in traditional manufacturing way. So what I mean by this is there had been a lot of 5-axis machining, brazing operations, complex assemblies, mating parts. And so all of that required pretty tight tolerances during the manufacturing process, some stringent certification, and on the certification itself, that was essentially a legacy and is still a legacy from the old days when NASA was dominating this space, especially with the human space flight. And so NASA was dictating a lot of the requirements that are still in place today in terms of, material compliance with certification. Now, what's happening now is a lot of space companies, the new space companies, they're transitioning from traditional manufacturing to additive manufacturing. So what it means, in practice is, you would 5 or 10 years ago, you would see a bunch of 5-axis machines in the space factory. Now, it could be just one 5-axis machine and 4 3D printers. Or it could be even those 4 3D printers, one of them could be a combination of a 5-axis machine with a 3D printer together in one machine. So that's one difference, one sort of development that happened over the years. The other development is access to computer technologies now is more affordable than before. So before, there used to be large companies that give you the computer software for quite a bit of money to license. Nowadays, there are a lot of startups that are innovating in the software space, specifically for manufacturing. And so you can do modeling, and that includes CAD modeling, fluid modeling, at the much smaller budget than before. And so that gives you the ability to iterate at the much smaller budget as well. And so that opens up the possibilities to iterate much faster than before. Let me add to that, nowadays there are CAD software packages that give you a direct linkage from your CAD model straight to the 3D printer. Some packages, they can give you hints and analysis on whether your model could be printable or not, or where to improve the model to make it more printable and lower cost.
And have you leveraged that approach at your company?
Yeah, so we leverage all of the above, and that's how we achieve affordability in our engines.
That's great. I know a lot of folks on the call definitely have dabbled in the additive manufacturing space, 3D printing. It seems to be definitely the here and now, and even the wave of the future, becoming more and more prevalent. So I know you spoke a bit with your analogy of farmers and then a parking lot with spaces to identify capacity. Are there any other use cases that your technology could be applied to manufacturers?
Yeah, so we've spoken about farmers, parking lots, the ships, but in general, we're talking about big data in space, Earth observation in space, right? And so let me start answering this question by saying that there's a lot of startups right now that want to do money in space through this data through providing data. And so, but what does it take? Does it take just one small satellite, or does it take 10? Well, it turns out you need something like a grouping of 50 satellites. So a constellation of 50 satellites is sort of a magic number at the moment. And that's because you need an even coverage over some area on Earth that you are trying to observe. And so imagine if you had just one satellite, it would zip over that point on Earth, and then you would lose coverage for some time until the satellite makes the complete round around Earth to get back to that spot. Now, if you had 50 of them that are evenly spaced around the planet, then you could get even coverage of that point on Earth that you're trying to observe. And so 50 satellites is what you need sort of as a minimal amount to make a meaningful business. And so what does it mean for this audience is there's going to be, and there's there are now and are going to be a lot of people that are manufacturing the small satellites, control systems for those small satellites that will keep the constellation in its geometric shape, essentially, in space that is required. And so we're talking about navigation components, we're talking about synchronization, all of that. There's a lot of innovation also that is going on in optics and satellite technology. So that is another area that is going to be very capital sort of intensive. There's going to be a lot of investment in that area as well.
And can you dive a bit deeper into the optics portion? I haven't really heard much about that space.
Yeah, so we started this discussion by saying that a small satellite nowadays is about this size of a box. And I don't know, with the zoom window, it may be hard to see a scale, but imagine a small satellite being roughly the size of your own head. So that is what we're talking about. Now, why is that the case? So let me start by saying that in 10 years from now, we're looking at small satellites of this size. That is where things are going. So from this size to this size. What's the problem now? Why can't we just launch these things into space, and 50 of them, to make money, right? Well, the answer to that is we're limited by the lens. The lens is essentially driving the size of the satellites now. The optics obviously needs to be precise to make meaningful observation on Earth. And so right now, people are innovating quite a bit in the lens technology. Some of them are traditional glass style technologies, but people are rapidly moving toward additively manufactured lenses. Again, additive manufacturing comes into play, right? And synthetic lenses, those are the lenses that are grown like crystals. And again, some additive manufacturing could be involved in those processes as well. So we're talking about dramatic cost reductions and size reductions when you are talking about the modern space.
That's fascinating. Almost like how you had these supercomputers, and over time they've gotten down to just a tablet, right, or a phone in your pocket. And forgive my elementary question here, but those head-sized satellites that you speak of, right? How many of those are up there in space?
So at the moment, we're talking about 5,000, give or take, and that number is growing every day, essentially, because, well, right now it's the large companies like SpaceX and Blue Origin that are getting their satellites up there in really large constellations. But more and more smaller companies are emerging that are building constellations for the purposes that we talked about. The field of crop in Eastern Washington, the parking lot on Trader Joe's, parking lot, ships, etc. So more and more of the smaller companies are emerging that want to launch those constellations into space. And so, so that's what's going on. 5,000, give or take, right now.
Okay, that helps frame the scale that we're talking about.
By the end of the decade, it's going to be easily 40, 50,000.
Wow, exponential.
Yep.
And when you speak of constellations, my mind automatically goes to Orion's Belt or the Big Dipper, right? But you're speaking of clusters of satellites up there, right? In a certain grid?
Yes.
Okay.
Yeah, it's essentially a rigid grid of evenly spaced satellites. So You could imagine something, well, in the simplest form, right? It could be a pyramid. If you imagine a pyramid, well, that's a very small constellation. And if you add more nodes into that constellation, then you get to the evenly spaced constellations that we see nowadays.
Fascinating. And I have tons of questions, but definitely want to open this up to the audience as well. I don't want to hog all the time. So if there's any other questions from the audience, please do ask.
Hey, this is Kirk. Max, I'd like to hear about, is there use for composite materials in the rockets?
Yeah, for sure. So especially with the small rockets that people are trying to build now, the smaller startups, the tanks in those rockets that carry the fuel, a lot of the times they're built out of composite materials.
And with all the activity taking place with these smaller rocket systems, would you say the Pacific Northwest is definitely a hub with a lot of activity taking place and more to come?
Yeah, definitely. Pacific Northwest is the place to be right now. It's quickly becoming the second largest hub after LA. Personally, I'm biased. I hope we overcome the legacy of LA and become larger as a region.
Yeah. So Max, what kind of fuel is being used right now? So Norman mentioned this earlier, but this is essentially rocket fuel, taking it up right now. What does that consist of?
Yeah, so for a long time, rockets have been using, especially the government rockets, they have been using kerosene as the fuel and liquid oxygen as the oxidizer. So if you think about the Apollo program, those Saturn V big launch vehicles, they used to be a kerosene fueled rockets. Then fast forward to space shuttle days, those space shuttle rockets, they used to be hydrogen fueled. Nowadays, more and more companies are switching to methane, to natural gas to use as a fuel. That is sort of the new fuel that a lot of people are moving into.
I used to work in the Air Force. I was a logistics officer, and part of my operation was refueling aircraft. And JP8, Jet A was, jet fuel essentially. How different is the type of fuel source that rockets use compared to aviation and aircraft fuel?
Yeah, so JP8 and Jet A, that was the sort of fuel that was used in the large Apollo program rockets. And there was a slight difference in the naming convention. That fuel was called rocket propellant or highly refined kerosene, which is essentially what the Jet A is. But then in the space shuttle days, people moved on to hydrogen as one of the more traditional fuels. Over time, people realized that hydrogen is very expensive to handle. And JP8 or Jet A, it has its own limitations in terms of keeping the rocket engines cool in flight. And so, out of that emerged that school of thinking that methane or natural gas could be the fuel of the future. And the reasoning there is that methane is very abundant. It's the second most abundant commodity on the planet right now that is traded, transported, sourced. It's also cheap because of its abundance. There's a lot of infrastructure built around methane. And so there's a lot of pluses that go with methane that people are considering.
And a quick personal question, a divergent from all this technical talk. So I mentioned I was in the Air Force, and whenever I watch military movies, I can quickly pick out if their uniform is incorrect or they're not supposed to wear their hat indoors, things like that. When you watch space movies or rocket movies, Apollo 13 or Armageddon, do you find yourself also picking on those Hollywoodisms that are just outlandish and not realistic at all?
Yes, yes, especially the sound effects in space. So space is a big void. There is not a lot of substance in space, literally speaking. And so because of that, it's hard to uh, convey sound through space because there's literally no medium through which a sound can transfer. And so, but what happens a lot of times in the movies, you hear those sound effects, with the stereo effect, and those are simply not true. Things are quiet in space.
The things we just take for granted and don't even realize.
Exactly.
Hey, Max, I was going to ask you, you have a background having worked with Blue Origin and SpaceX. Your background is very fascinating, by the way. I think people would be very interested to hear about some of the projects and things that you've worked on. But because I think you have, I mean, we're talking about small satellites, is what you're focused on right now in propulsion systems. But where do you think space as an industry is going? Where's NASA going? Where's Blue Origin going? SpaceX? What do you see happening in the bigger space industry?
Yeah, so that's an excellent question. It kind of dives deeper into the happenings of the day. Space used to be sort of like a club of big, heavy members, and those members, they were primarily interested in defense and space exploration, and exploration was to other planets. Looking at a field of crops in Eastern Washington was definitely not a priority. But what's happening now is, with the computing technologies coming down in cost, was additive manufacturing emerging, space is becoming more accessible. That small club of limited members is now growing and growing day by day, and smaller members are coming in. Now, with the membership growing, you would naturally see specialization. Some people, especially the big members, the old members, they will still be pursuing space exploration to Jupiter or Mars or Moon, trying to build a moon base. But there's going to be a lot of those newer, smaller members that will be thinking about the field of crops in Eastern Washington, and trying to kind of find their niche and spot under the sun by providing those sort of services. So space is becoming less spacey, so to say, now.
Do you see what Space Force is focused on? I'm guessing it's security minded, but do they have a mission that's bigger than just I don't know, protecting satellites or protecting what's happening in space?
Yeah, so Space Force obviously has defense mission as their primary objective. What I could say is that one of the problems that they're interested in on a pretty serious level is how to use small, affordable rocket technology, propulsion technology, to augment the defense purpose. And what I mean by this is, we in the United States, we're not the only ones that recognize the cheaper computing technologies and additive manufacturing. there's a lot of other countries and people that think the same way. And some of those people are, are ahead of us in some ways. And so one of the ramifications here is that, for example, some of the countries, they have now technologies to launch robotic satellites that can approach our satellites in space, our space assets, and essentially deactivate them. If you can imagine a box with essentially crab arms on it, and that box flies to our satellite and does something to it to essentially turn it off. So we don't want that to happen. And the satellites, the defense satellites that we're talking about are those classical school bus size satellites up there. Now, the question becomes, in the event of an enemy taking out our satellite, can we quickly replace that school bus satellite, the big one, with those tiny head size ones, a constellation probably of the tiny ones that will do the same job as the big school bus size satellite that got deactivated. And so, well, then the question becomes, well, how do you make it happen rapidly? So you can build small satellites, okay, but can you launch 50 of them on a 2-week notice? That is the question. And so Space Force and Air Force are looking for solutions to that problem. And our company, we are trying to answer this question by contributing with the affordable engines that are they're so affordable that it essentially allows to build rockets that are so cheap that the Space Force can launch them without regret. And that is, the term that the military use is maneuvering without regret. So that essentially means, say you launch 50 of those small rockets and something happens with 5 of those rockets or even 10 of those rockets. They don't reach the final, target point in space. You can afford that because all of them are so cheap. You will still have the other 40 coming to the target and doing the job of the big school bus satellite that got deactivated. Does that make sense?
I've been looking for opportunities for manufacturers to look forward to, but it sounds like there's going to be a lot more happening in space. And because you mentioned there's so much money in it, the use cases get very exciting. And I'm sure you've just scratched the surface of use cases. But the idea, though, is if a manufacturer could contribute in terms of it could be materials or fuels, or I can think of, I don't know, I've walked into some relatively small shops that are doing some one-off work for Blue Origin or SpaceX. So it seems like there's an expanding need for manufacturing in space.
Yeah, definitely. If there are manufacturers, small shop owners in the audience, what I would definitely point out is that now is the time to seriously consider additive manufacturing in the course of business. At least have one machine present in the shop and start tinkering with it, at least on a novice level. And I'm saying that because, what I'm seeing happening is the traditional manufacturing is moving very, very quickly into additive manufacturing. Now, there are, of course, limitations with the additive manufacturing. So, for example, now the limitations are that very complex parts, they can be printed and eliminate a lot of the jobs like welding, like brazing, but the printed parts are still rough in terms of the surface. Some printed parts, especially the large size parts, they don't hold tolerance well because of the warping issues during the printing process. There's some thermal distortions going on in the parts, but nevertheless, nowadays we can get 3D printed parts that are within 5,000ths of an inch of a tolerance. And 5,000 of a tolerance, this is a pretty serious precision that people are content with. Essentially, what's happening is people are thinking, okay, can I build my engine, with the majority of the parts being at 5,000 tolerance, and only reserve 20% of the parts or 10% of the parts to 1,000 or 2,000 tolerance. And that drives this whole game of, okay, if 80% of my parts are loser tolerance, I can do printing on these parts, and then only 20% of the parts I need to do the 5-axis machining. And so that kind of drives the capital expenditures in the shop by saying, okay, I really need 4 of my 5 machines being 3D printers, and just 1 of them being a 5-axis tight precision machine. Hope it makes sense.
Oh, I think that's really great insight. And sorry, Norman, I have a couple more questions or observations, but one is, I've been really privileged to get to know Max and to work with him on a project or two. But in some of my research, Max, I saw there was only like 180 launches in 2022. So at this point, there's not a lot, relatively, there's not a lot of launches. But that's one of the parts of the vision. And I saw that the average Falcon 9 launch was a cost of about $67 million.
Yeah, that's exactly what we're trying to solve, right? That goes back to the beginning of our discussion. Right now, you have a big steamboat on the Mississippi River. You don't have smaller kayaks or canoes or private boats, that can just swim around the big steamboat. Or you have the transcontinental railroad, a big train was 20 cars behind, but you don't have the cars on the highways. And that's why there's only 180 voyages of that steamboat on the Mississippi River in 2022. We're trying to fix that problem. We're trying to say, okay, now is the time, now is the inflection point in industry to make those smaller cars, smaller boats happen. And so, there's quite a bit of data out there, but just one of the data points that may be useful for this audience. It's projected that there's going to be at least 3,500 launches by 2030.
Wow.
In that 2030 year. So you can see the jump, right? There's 180 of them in 2022 and 3,500 of them in 2030. And that's a pessimistic projection as of now. And it's pessimistic because, again, we're talking about transition from this satellite size to this satellite size. So things are going naturally smaller and smaller and smaller. And you can expect the launch quantity going bigger and bigger and bigger to launch these things.
So Max, could I just interject here that something for everybody to keep in mind, that when you're talking about that scale of going from 180 launches to the number you were mentioning, that if you think in terms of the type of manufacturing, so right now you're prototyping, right, Max? You're testing, you're prototyping, but when companies come to you and say, I really want to get more rockets up into space for less money, you're going to have to kind of probably outsource some of that manufacturing. It's kind of what I'm hearing.
Yes, that's exactly right. So we plan to produce 700 of our engines a year at full capacity. And of course, you know, and our company is just one of the examples, but there's going to be, if there's just one of us now in Washington State, there's going to be obviously 10 of companies like ours by 2030 because of how things are going, right? So, and some of those companies, they will decide to go with a vertically integrated model, right? To have their own machines in their own shops, but majority of them are going to be outsourcing their manufacturing to others that have the machine shops and machines specifically for production, for outsourced production.
Yeah, there can be a lot.
This community. That's good news.
That is
Yeah,
really
definitely. So, if you take away something from this discussion, right? What I want you to take away is that, well, first of all, space is being democratized rapidly, right? It's not, it's not an arena of white coats and, and bunch of scientists, in a shiny lab. It's becoming a business for normal, ordinary people. So that's one. The other one that we spoke about, the manufacturing shops and the outsourcing, it's not going to be just the space companies that are going to benefit from these developments, but the entire ecosystem that surrounds those companies. So anybody from a powder supplier to the 3D printers, to raw materials, metals, high temperature metals, to the traditional machines, the machine makers. We talked about engine manufacturers, rocket and satellite manufacturers, lens builders, service providers, internet consumers. So it's the entire ecosystem that we're talking about.
And
It's essentially the same moment now in space as when we had IBM, making, school bus sized computing machines. And now we have an iPhone in our hands.
very exciting times right now. And one final question, Max. So for folks that want to learn more about the exciting work that you're doing, where can they go to get more information?
So as it pertains to this audience, what I would say is there's a lot of additive manufacturing conferences going on across the country every year in several different formats, and it's pretty easy to Google them and find which one fits your particular business the best. So that would be one avenue. The other avenue is there is some large 3D manufacturing companies out there. The industry as a whole is maturing and kind of solidifying, and some big players are emerging. So one of the big players is Stratasys Direct Manufacturing. That's just one of the examples. And people can go on their website and essentially sync up with the latest developments in additive manufacturing. Obviously, people here in the audience, they are probably well aware of the traditional manufacturing and the machines in that space, so I'm not going to talk about that. In terms of what's happening in space, spacenews.com is a good outlet that kind of talks about the big news in space. But there's also smaller outlets that are updating on a more frequent basis. So in LinkedIn, there's editorial called Payload, and so people can go on LinkedIn and look what's happening in space. So Payload is one of those that gives you literally like hour by hour updates in space.
I'm going to check that out. It's really cool. Well, Max, we're just about at our hour, so I would like to thank you once again for making time to join us here and give us a peek behind the curtain on all the amazing work that you're doing, as well as a glimpse into where this industry is going.